Section 4.2 is the standard form of a quadratic function. I can graph quadratic functions written in standard form. Big ideas here. Any quadratic function is a stretch, compression, reflection, and/or translation of the parent function y equals x squared. The standard form of a quadratic function is f of x equals, or y, ax squared plus bx plus c. For any quadratic function, f of x equals ax squared plus bx plus c, the values of a, b, and c provide key information about its graph. So if we look at the take note on page 203 here, I've put it up as a picture here as well. The graph of our parabola happens anytime we have an x squared, so as long as a is not equal to 0. So our first term, when it's in standard form, which means highest degree to lowest degree, biggest exponent to smallest, is squared, then it's going to be a parabola. So again, standard form is ax squared plus bx plus c. If a is greater than 0, that means it's positive. So we're going to have a happy face parabola, and our parabola opens upward. If a is less than 0, that means negative. We're going to have a sad face parabola. The parabola opens downwards. The axis of symmetry, so before we said the axis of symmetry was x equals h, now our axis of symmetry is negative b over 2a. We don't have an h in standard form, so it's going to be negative b over 2a. This you're going to want to know. That's going to be very helpful because just like it was when we were in vertex form, our h value, or whatever our axis of symmetry, our x value there, is also going to be the x-coordinate of our vertex. So our vertex is going to be found at whatever we get for negative b over 2a, and the y-coordinate we get from finding what the value of our function is at x. So we substitute it in. We find f of that value. So f of negative b over 2a. So again, to find our x-coordinate of our vertex, we use our axis of symmetry. It is a line, so we need the x equals here, negative b over 2a. Whatever value we get there, that's our x-coordinate. We plug that into our function in order to find our y-coordinate, and that's going to give us our vertex. We also have one more point here, our y-intercept. Remember, our y-intercept happens anywhere that x is x is 0. Y-intercept happens anytime x is 0. It's where we cross the y-axis at. And our y-axis is when x equals 0. So our point here is always going to be 0c, because if x is 0, we just get c. So here they show our axis of symmetry is at negative b over 2a. We have a point on our y-intercept, and they've reflected that, meaning they went 1 unit away in the other direction. Okay, remember, axis of symmetry means both sides of our parabola are the same distance away, just in opposite directions. And in order to find our vertex, which is on that axis of symmetry, they used what we got for the negative b over 2a, plugged that into our function, and got a value. Same idea here on the second one. The only difference is a is less than 0, which means a is negative, so it's a sad face parabola. Instead of over here where a is positive, so it's a happy face parabola. Example 1 had to do with table of values and a graphing calculator, which we don't have, so we're going to skip that and go right to example 2. Here we're going to graph a standard form quadratic function. So different than vertex form, if I look here, I don't have it in vertex form, so I can't pick out my translations. When it's in standard form, we have to find our axis of symmetry. And in order to do that, we find negative b over 2a. So here I'm going to pick up my values. A is going to be 1, b is going to be 2, and c is going to be 3. X squared is a, x is b, constant is c. So my axis of symmetry is negative b over 2 times a. So my axis of symmetry is the line x equals negative 1. The line x equals negative 1. So at negative 1, I'm going to put just a dotted line here to show my axis of symmetry. You don't have to have that, but it's going to be helpful to help me remember where I'm symmetric about so I can reflect my points rather than having to find more. Remember, anytime we graph something nonlinear, we want at least 5 points. So now that I know where my axis of symmetry is, I know that my vertex falls on that axis of symmetry, which means this x value that I got is going to be the x value of my vertex, and I plug it in order to find y. So for my vertex, again, it's an ordered pair. My x is always the same as the x for my axis of symmetry. I plug it in to find y. So I take -1 squared plus 2x -1 plus 3. Gives me 2. So at -1, 2, I have my first point. I'm going to check here. Is this going to be a happy face or a sad face parabola? Well, my a value is 1, which is a positive number, so it's going to be happy. Okay, that's good to know and just kind of keep in the back of our noggins to make sure that we check and go from there. Now, after I find my vertex, I can also find my y-intercept. Remember, my y-intercept always happens at 0, c. It's always going to be my c value. So here my point is 0, 3 for my intercept. And again, we're talking y-intercept. I can reflect that point. If you look here, we are 1 away from our axis of symmetry. So starting from my axis of symmetry, I'm going to go 1 away in the other direction. Same height, just opposite distance, or opposite direction away from my axis of symmetry. That gives me 3 points. To find my last 2 points, I'm going to do a little bit kind of like a table of values. Here I'm going to find a 4th point by picking another x value. Doesn't matter what we pick, but we want to pick something close to the points that we already have. So I have points at -2, -1, and 0. So I'm going to use 1. Okay, I don't know the value of 1, but it's close to them, so it'll probably fit on my graph. And 1's easy to calculate. So here it's just like, again, like if we had a table of values. We pick an x value, find our y. I'm going to substitute it in. So my point's going to be 1. Plug it in for x. 1 squared plus 2 times 1 plus 3. And I get 6. So at 1, 6, I have a point here as well. I also could have used like -3 is close to the points that I have. I could have used like -1/2, but that's just a little bit harder to calculate in your noggins. So I used 1. Check here, we're 2 units away. So we go 2 units in the other direction. It looks like we're going to have a happy face parabola, and we should. So we are correct. We can connect these dots. Again, make sure we go out and not curve back in. And that is what our parabola will look like. 5 points. Vertex, intercept and reflected. And then our 4th point, we just picked an x that's close to the ones we have, plugged it in, and flipped it. Okay, it's kind of like making a table of values, but here we at least know where to start from, rather than just picking a random x like -2. Well, we already know that. -1 we already know. 0 we already know. 1 we can find and go from there. Here's another example. So again, it's in standard form. So whenever it's in standard form, we are going to start off with our axis of symmetry, -b over 2a. So our axis of symmetry is always x equals -b over 2a. Here my a is 4, my b is -16, and my c is 10. So negative, or the opposite of -16, which will give me a +16, over 2 times a, is going to give me 2. So my axis of symmetry is going to be the line x equals 2. So at 2, I'm going to draw a dotted line just so I remember where to reflect across. Now that I know my axis of symmetry, I can find my vertex. Remember, our vertex is our maximum or minimum, our highest point or our lowest point. Here it's going to be a minimum because a is positive, so we're going to have a happy face parabola. So to find our vertex, which is that point, remember our x value on our vertex is always the same x values from our axis of symmetry. I plug that in to my function, in order to find the value of my function at 2. And I get -6. So 2, -6 is my vertex. Okay, first point. Now, I'm going to find my y-intercept. Remember, our y-intercept is always at 0. X is 0 when we have a y-intercept, C. So at 10, I have my y-intercept. I can reflect that point across my axis of symmetry. Here I'm 2 units away. So I'm going to go 2 units away in the opposite direction and get my third point. So again, y-intercept is my second point. My third point is its reflection. To find my fourth point, I pick any x value that I don't know, but again, we're going to want something close to the points we already have. So here I could pick like 3 is in between points we already know or close to them, or I could pick 1. I'm going to do 1 because I don't already know that value, and it's the easiest to plug in. But 3 would have worked as well. Again, we want something close to our point so it fits on our graph, but not something we already know. So I'm going to say, what's my point when x is 1? So I plug in 1 for x. And here I get -2. So at 1, -2, I have a point. I'm 1 unit away from my axis of symmetry, so I go 1 unit away in the other direction. And that gives me my fifth point. So again, my fourth point I just found, and my fifth point was a reflection. Now that I have my points, I can connect them with curves to make my parabola. Double check. It looks like it's going to be a happy face, and I should have a happy face, so that's right. These don't have to be perfect lines, but again, make sure that we're going out, not curving back in, and that these are curved and not like connected with a straight edge. So it don't have to be perfect. Your points are going to be what I'm looking for, and then that the effort was made to make it curved. Feel free to pause here and give this a try if you'd like. A is going to be -2, B is going to be 2, C is going to be -5. We start off with our axis of symmetry, which we find at x equals -b over 2a. So here I have -2 over 2 times -2, which gives me 1/2. So my axis of symmetry is x equals 1/2. So at half, I'm going to put a dotted line. That's going to remind me where I reflect about. Now, the other cool thing about that -b over 2a is when we find our vertex, we know that the x-coordinate of our vertex is always on our axis of symmetry. So I know my vertex is going to have an x-coordinate of 1/2. I plug that into my function. Here, don't forget we square first and then multiply. And I get -4.5. So at half, -4.5 is my vertex. This looks like it's going to be a sad face parabola because a is negative, so let's keep that in mind. Next, I can find my y-intercept. My y-intercept always happens at 0, C. So at -5, I have a point, half away, so I go half away in the opposite direction and have my third point. To find my fourth point, we plug in any value we don't know. Here I already know 1 and 0, so I'm going to plug in a -1. I'm going to find when x is -1. And I get -9. So I have a point at -1, -9. I can reflect that. I'm 1.5 away, so I go 1.5 in the other direction. Connect to my dots, and there we go. And I will finish this section in another video.